In this topic, we'll look at the earliest Greek philosophers, what their ideas were, and what they learned about the universe. We start with Thales. Thales lived around 624 to 548 BC, and he's widely credited as being the first philosopher, a lover of wisdom. He lived in Miletus, which was a Greek colony on the Ionian coast. He learned how to predict the weather and actually used this information to get quite rich by cornering the market in olives. And yet he's also credited with the first anecdote of an absent-minded scientist, apparently falling into a well because he wasn't paying attention, looking up at the stars in the night sky. Herodotus predicts that Thales was talking about eclipses in 585 BC and actually predicted an eclipse during the battle between the Medes and the Lydians. There's an evocative scene in Herodotus describing this. These two fearsome battle-hardened warriors fighting each other on a plain on a rugged coast of Ionia, when suddenly the sky darkens inexplicably and the temperature drops. It seems like an act of God, and the warriors fall to their knees, some leaving the battlefield dazed, confused, in tears, because they don't know what's happened. Thales, however, has used ancient Babylonian eclipse prediction records to predict this eclipse, and so it's the beginning of the exertion of science onto natural phenomena. He's credited with being the first Greek mathematician, and he sought to explain the nature of the cosmos as arising by natural laws from some first principle. Aristotle said this was water, so all things were created out of water, and were water in a deeper or more fundamental sense. The whole idea of everything coming from something is a Greek idea. Then we come to Anaximander, who is a younger contemporary of Thales. He gave up the idea of any material as a primal essence, instead postulating the infinite. Matter has no defining property except being infinite. All things come from the infinite and go back to the infinite, and an infinity of worlds have existed and perished in the world. This is an audacious idea, the infinite universe, far before astronomers ever thought of the idea. He's also credited by Herodotus with making the first map of the world. Then we come to a pivotal figure in the history of science and, of course, of mathematics, Pythagoras. Born in Samos in Ionia, he was supposed to have traveled widely to Egypt and Babylon. There are no writings left from Pythagoras, but his school persisted for 200 years, and many of his followers passed on his word. Pythagoras was actually banished from the Greek mainland, and his group of mathematicians had the air of a cult. He founded a school in southern Italy. He was the first to use the word cosmos, and in the Greek, the word cosmos has a nature of rational harmony beyond just describing the universe itself. Pythagoras' fundamental idea was that everything is number. Everything comes down to number. And he imagined the harmony of the spheres, that every heavenly body produced its own tone. He didn't think it was literal music, but he imagined that someone suitably enlightened might actually hear the notes. He was well aware of the arguments for a spherical Earth. The next pivotal figure is Plato. Plato didn't contribute to science directly, but in his metaphysics, he had the allegory of the cave, saying that we see imperfect shadows, but perhaps a philosopher can see the true nature of things. The allegory of the cave is very influential because he's saying that the data and the evidence of our eyes is imperfect, the flickering shadows cast by an object when we may not see the object itself. His cosmology is summarized in his book, The Timaeus, where a cosmos is created by a deity from primordial chaos, and the fundamental elements are four: earth, air, fire, and water, where everything else is combinations of those. This is a very primitive form of the periodic table, as we might recognize it. He thought that mathematical reasoning was the only path to certainty, and so he echoed the ideas of Pythagoras. His work survived through Rome to the Middle Ages and was translated and passed around Europe, so his ideas survived well for 2,000 years. He founded the first university, called the Academy, in Athens in 387. It lasted for 300 years. Then we have another figure of great importance to science and astronomy, Democritus, called the laughing philosopher due to his cheerful disposition. His most profound and influential idea was the atomic theory. All matter is made of atoms. They're indivisibly small. They're indivisible and indestructible and in constant motion. And properties like color and taste are secondary property of collections of atoms. This is an audacious idea. Atoms were not actually directly demonstrated in physics for another 2,000 years, actually until the late 19th century. He used a logical method to get to this idea. He imagined you take a grain of sand or a small rock and cut it with a sharp knife over and over again in half. And he asked, what would you imagine that happened as the rock becomes a grain of sand and eventually becomes so small that you cannot cut it with the knife? Do you imagine that this subdivision would continue forever, in half and half again to the infinitely small? Or do you imagine this progression must end with some fundamental indivisible unit? Democritus thought it was logically implausible that it would continue forever, and so logically he came up with the idea of fundamental units of matter, or atoms. This idea, subdividing a rock or a grain of sand with a knife without actually doing the experiment, is a very important tradition in science, continuing to this day, of thought experiments. The Greeks had no experimental science, so they used thought experiments or conceptual experiments to make progress. And these ideas matured with Epicurus. In the universe, there are similarly profound speculations. With Archytas, a commentary in the 5th century, we see the idea of a warrior going to the edge of the universe with a spear and hurling his swift spear and asking, what do you imagine happens to the sphere? Do you think it continues forever, and if so, into what? Or is there an edge to the universe, and if it hits the edge of the universe, what is the edge made of? And then what is the edge inside of? And so, logically, the Greeks imagined there is no center and no edge to the universe. The universe must be infinite and must contain infinitely many atoms. And perhaps an infinity of worlds might be teeming with life. These are extraordinary ideas to have thousands of years ago, really with no evidence to support them, obtained purely by the mechanism of logic. We can summarize this time in the painting, The School of Athens, a gorgeous painting by Raphael that's visible in the Apostolic Palace of the Vatican City. And in this painting, annotated, we can see all the major philosophers. At the center are the great philosophers, Aristotle and Plato, and the symbology of their representation is also important. We have Plato painted to look like the great painter Leonardo, with his hand pointing up to indicate the primacy of ideas. We have Aristotle, empirically minded, more practical, with his hand pointing downward to indicate the earth and being rooted in experiment. And then we have Socrates, who is hugely influential in philosophy, not so much in the history of science. If you want to know where the painter is, you can see him on the far right. Peeking in from the side is the artist, Raphael. To keep track of the philosophers, perhaps it's useful to have a song. Here's one from Monty Python, including all the Greek philosophers and the other major ones since then.
Him and your cat was a real pissant who was very rarely stable. Odd digger was a boozy beggar who could think you under the table. David Hume could out-consume Wilhelm Friedrich Hegel, and Wittgenstein was a beery swine who's just as sloshed as Schlegel. There's nothing Nietzsche couldn't teach about the raising of the wrist. Socrates himself was permanently pissed. John Stuart Mill, of his own free will, on half wine and shandy was particularly ill. Later they say could sing it away, half grain of whiskey every day. Aristotle was a bagger for the bottle, Hobbes was fond of his dram, and René Descartes was a drunken fart. I drink, therefore I am. Yes, Socrates himself is particularly missed. A lovely little thing about a bagger when he's pissed.
The next philosopher in our tradition is Eudoxus, a student of Plato who possibly taught at the academy and traveled extensively in Egypt. He's the most famous mathematician in classical Greece. He made the first use of axioms and the first rigorous definition of numbers. He had a very clever method for subdividing complex objects to get areas and volumes. And this is a precursor, essentially, of calculus. Eudoxus had a cosmos built from concentric spheres centered on the Earth, For the sun, one sphere, and then for each planet, another sphere. And so these concentric spheres, made of a mysterious crystalline substance he didn't specify, was a nested shell universe, like Matryoshka dolls, and the outermost sphere carrying all the fixed stars. He had the first mechanism proposed to explain the retrograde motion of planets. Here we see a little animation of how circles embedded within each other with differential motion can create the apparent backward motion of an object attached to one of the circles. This was a clever way to use circles in an Earth-centered cosmology to explain the retrograde motion of planets. The next figure is a huge figure in the history of ideas, Aristotle, a student of Plato until Plato's death. He was invited to tutor Alexander the Great. He might have considered this task a failure because Alexander didn't seem so interested in the academic knowledge that Aristotle had to provide. He was more interested in fighting in battle and going off with his army to create the greatest empire the world had ever known. However, he did benefit from his vast knowledge and his vast empire. Every time Alexander would travel to a distant land, he'd bring back Alexander's samples. And so Alexander the Great gave Aristotle what was the greatest zoo in antiquity. Aristotle returned to Athens and built his own school. Having been passed over to be the head of Plato's academy after Plato's death, he did the natural thing, went down the road a few miles, and founded the world's second university, the Lyceum, of which he was the director. He was a prolific writer and wrote many treatises. Probably they were textbooks for students. He's the most important source of a lot of ancient philosophy, in part just because he wrote so much. But he was also a voracious reader of previous thinkers, and he thought about every subject. In De Caelo, he dismisses the idea that the Earth rotates or orbits. He does the thought experiment of shooting an arrow straight up and thinking, well, if the Earth rotates, the arrow would fall behind the archer. Aristotle was concerned with the actual universe, but his arguments were essentially metaphysical. By arguing the universe as a sphere, it was because the sphere is the most symmetric and hence perfect of shapes. And by arguing that the universe is finite, he imagined that a body infinitely far away cannot rotate in a finite time, which seems completely reasonable. Aristotle employed the general ideas of Eudoxus, but conceived of his model literally, a Rube Goldberg device, a complex mechanical device. He uses Eudoxus's spheres and he puts it together in a mechanistic whole. To explain the awkward effects of non-uniform moving planets, he needs off-centered and multiple spheres to explain these finite objects, and in the end needs 55 spheres to explain the motion of 7 objects. The outermost sphere moves under the influence of the prime mover, his version of God. It transmits the motion to all the spheres below it in succession. The bulk of Aristotle's output on every topic from cosmology to biology to ethics, government, leads him to be called the philosopher by medieval Christians. His work on physics was hugely influential for at least 2,000 years, even though some of it, as we'll see, was wrong. Aristotle had a geocentric model of the universe. And the reason why the Earth is at the center of the universe is because humans are the pinnacle of creation. The world would naturally go around us. The reason the Earth isn't moving is it's at the center of the universe. We don't feel any motion. His thought experiment of the arrow shot straight into the air. So Aristotle's geocentric model was rooted in common sense as far as he thought, as well as the purity of his ideas. How did the Greeks explain planetary motion? It was difficult. The underpinnings of the Greek geocentric model were that the objects had to move on perfect spheres. And since their motions were not uniform, you can't rotate a sphere at a constant rate and have a uniform motion. And that means they needed many spheres. So the system became quite complex, quite cumbersome. And so by the time of Aristotle and the height of the Greek model, it was a very complicated mechanism and not particularly elegant at all, in part to explain the retrograde motion of planets. And that's the end of this topic.